Okay, so this video, I ended off on the last one on number 14. This one I'm going to go to 22 on the evens. And 16 is a little bit of a tricky one, so I wanted to do that with you. So first of all, you look at this and it's a quotient. And I want to simplify this. And I'm like, wait a minute, how am I going to do that? So I'm going to show you a trick. I'm going to take 2. I'm going to split it up as a 1 and a 1. Okay, so I've got 1 plus 1 plus x squared all over 1 plus x squared. Okay, so you're like, okay, I get that. Now watch. I'm going to put this in parentheses and this in parentheses. That does not mean you can cancel this, but I can split it up into, I can divide each by that. So I have 1 over 1 plus x squared plus 1 plus x squared over 1 plus x squared. Okay, that's how you would split that up. Now I do see here that these will cancel out, make a 1. So I have f of x is going to be looking a little different. It'll be 1 plus 1 over 1 plus x squared. And you're thinking to yourself, now why did she do that? What good is that going to do? Well, when I looked at this looked very familiar. It looked like the derivative of the tan function. And so I went and looking back at what we did for our derivative cards. So let me go back. So if I look at the antiderivative of tangent, here it is right here. If I go back, it's secant squared. I'm like, okay, it's not tangent, so let's keep looking. It looks familiar to me. Oh, like at 1 plus, this has a k squared x squared, but it's inverse tan. Remember, it was 1 over 1 plus u squared times u prime, so it's inverse tan I'm looking at. That's what I'm looking at. So I'm going to come back over here and say this is inverse tan. So when I do capital F of x, okay, the derivative of 1 is just going to be x plus the antiderivative of 1 plus 1 over x squared is inverse tan of x, and don't forget your plus c. So that one is a little tricky because I did this in class and people said it reminds me of tangent. I said, well, it's inverse tangent for one thing. And then the other thing is you have to kind of look it up to say, oh, and play around with it to get that. Okay, so let's try 18. 18 is kind of set up a little weird. And they gave us some information. So here I have f of x equals 4 minus 3 times 1 plus x squared to the negative 1. So I'm just going to rewrite it to this way. 4 minus 3 over 1 plus x squared. That kind of looks like inverse tan to me. And notice they gave us f of 1 is 0. Now that's a capital F, so I have to do the antiderivative, and hopefully that'll help us find our constant c. So I'm going to do capital F of x, and when I do the antiderivative of 4, that's going to be 4x minus, and then this right here, we just did one like this. This is inverse tan, so I've got a 3 there. So it's going to be 3 inverse tan of x, because that's what the antiderivative is. And then I got to put my constant c. Now, by them giving me f of 1 is 0, wherever the x's are, I can put a 1 and put it equal to 0. Maybe we can figure out what c is. So this one's a little bit complicated, so kind of follow through with me. So I'm going to do f of 1 equals 4 times 1 minus 3 times the inverse tan of 1 plus c, I know, equals 0. Okay? And then I look at it and say, okay, f of 1 equals 4 minus 3 inverse tan of 1 plus c equals 0. So I'm solving for c. I want to know what the constant is. I know my table, so I'm pretty happy. I know the inverse tan of 1 is pi over 4. So I really have, I'm going to come over here, 4 minus 3, and the inverse tan of 1 is 45 degrees, or pi over 4. So 3 times pi over 4 plus c equals 0. So I have 4 minus 3 pi over 4 plus c equals 0. And I'm going to solve for c and move those both over. So c comes out to be 3 pi over 4 minus 4, which is a constant, even though I don't care how ugly it is. So now I can actually go through and tell you what f of x is. And I'm actually going to move this down a little bit. So hang on a second while I move this down a little bit. so that I have some room here. Well, that was fun. Well, this is taking me longer than I thought. It was all together and then I moved it, so I'm not doing another video, so sorry about that, guys. Okay, so now that I have the room, I'm going to come here and do, actually, ready? F of x actually comes out to me, my original function comes out to be 4x minus 3 inverse tan of x plus 3 pi over 4 minus 4. That is my original function. So that's kind of interesting, besides me trying to move number 20. That was interesting. All right, let's look at 20 here. So that works is you can actually figure out what your constant is if they tell you more information. Number 20 is a little bit different, is that they are giving you the second derivative, and then they basically want you to go backwards and find your original function. But the only thing that's confusing is up here we've been using little f of x is the first derivative. So here it's kind of confusing where they actually tell you the second derivative. So we are going to go backwards. I am going to call it f prime of x. We have been using this as little f of x earlier. And when I do the antiderivative, okay, so I have 2x there, add 1, so that's going to be 1/4 x to the 4th, add 1, 1/7 x to the 7th, okay, and then I have my constant c, okay. Now, if they do not give you any more information, that's all you can do. But now they want us to go backwards again, if you will, and find our original function. So I am going to call it capital F of x, all right? So when I keep going and do the antiderivative yet again, I'm going to get x squared because I add 1, multiply by 1/2, plus add 1, so that's 5, multiply 1/4 times 1/5, so that's 1 over 20, x to the 5th. Add 1, that's 8, so it's 1/8 times 1/7 plus 1/56, x to the 8th. And then this is my constant c, so this is going to be now cx, I don't know what it is, plus d. So that's how I kind of want you to handle it. If I don't give you any more information, that is my original function. And c and d could both be 0. I don't know that, but that's all we're given. Okay, let's try 22. So when I do 22, it's the same thing. They didn't give us any information, but this one has a trig function in it. So we're going to use the trig square, and we're going to go backwards. So I'm going to do f prime of x, which is really our little f of x we're using. That's going to be now 3x squared, my antiderivative. The antiderivative sign is minus cosine of x. Now, you're like, how do you do that so fast? Well, I want you to remember the trig square, which is on the back of your card. So if they ask you for the antiderivative of sine x, you're going to go this way, so it's minus cosine x. I love that trig square. So let's go back, and then I've got a plus c. They want us to go one more back to our original function, so I'm going to change it to capital F of x. Do the antiderivative again, it turns to x cubed, and then minus sine of x, use your trig square, plus cx plus d. And so there is my original function. I just don't have any more information to tell you c and d. Okay? So that's what we did. We did 1 through 22. And now I'm going to do 29. So here's 29. This is the very last one. This is actually what I signed, but I wanted to do it with you because they actually gave you information so that you can go back and do it. So I have 29 is f double prime of x equals negative 2 plus 12x minus 12x squared. And they told us f of 0. So this is our actual original function. I kind of wish they would have done it this way. Capital F of 0 is 4, so that's our original function. And this is our first derivative, which we've been using as a little f. They're both fine. I just want you to recognize sometimes they switch back and forth. I'll make sure that you know for sure when we do this. So let's go backwards, do f prime of x, do our antiderivative of 29. So I'm going to get negative 2x plus 6x squared. You can stop this and do it yourself first and come back and look at it. Minus 4x cubed plus c. Okay, now I'm going to go here and use this because they told us that. Okay, so I'm actually going to put a 0 in for x and a 12 in for the n. So I'm going to do this. Ready? F prime of 0 is going to be negative 2 times 0 plus 6 times 0 squared minus 4 times 0 cubed plus c, and they said it equals 12. Well, this one is kind of cool because this is 0, this is 0, this is 0. So basically I can say, therefore, c does come out to be 12. So now I know that f prime of x, I no longer have to worry about this constant here. I can actually put a 12 there. So f prime of x actually comes out to be negative 2x plus 6x squared minus 4x cubed plus 12. And if you're uncomfortable with that, you can always do the derivative and go back and see if it ends up with what we have here, and it will, okay? Now they want us to go back and find capital F of x, if you will. So we're going to do the antiderivative again. So I'm going to do capital F of x, or f of x, if you will. And when I do this one, I'm going to get negative x squared, okay, plus 2x cubed, all right, minus x to the fourth plus 12x, and now I have another plus c. Okay, so I found capital F of x. Now I'm going to come up here and see that they gave us this, or this, whichever way you want to look at, that capital F of 0 is going to be 4. So we're going to do f of 0 is negative 0 squared plus 2 times 0 cubed minus 0 to the fourth plus 12 times 0 plus c is going to equal 4. And then I said, oh, therefore, because all these will cancel out again, c is going to equal 4. So now I know f of x, my original function, is going to be negative x squared plus 2x cubed minus x to the fourth plus 12x plus 4. And that is our original function. So this is all that I did in practice in class. That if you need to see this, I'm giving you the odds to work on. So go ahead and start from the beginning and practice the antiderivatives. And I hope this helped you.